Next talk from Adam Kubec, given from the sponsor company XRnanotech. So please share your screen.
Yes, thank you very much. I hope you can see it in full screen mode now. I take that as a yes. So yeah, I hope you have a great conference and good discussions amongst you. And I've seen a lot of interesting talks, and we are glad to be able to support SXNS here. And please let me introduce XRnanotech. And yeah. So we are a spin-off company from the Paul Scherrer Institute, and we have started off based from X-ray optics, or offering X-ray optics. And currently we are also offering all different sorts of surface structuring, surface treatments, and processing, which is connected to that. We have some main technologies, which is like from beam lithography, laser writing, and UV lithography. And typical structures include zone plates, gratings of various kinds, and nanostructures, of course. And we do have a lot of customers already in contact with synchrotrons, free electron lasers, academia, universities, and also high-tech companies. Today I will talk about XRnanotech. I will briefly introduce our current team. I will introduce the technology, and if time permits, I will also show some application examples which have been achieved using the technology from our company. So currently we are 5 people in the company, and we will have 2 more colleagues starting in first quarter of 2022. And we are also hiring more people in this year. So we are currently looking for business development intern, and we will be looking for more support later this year, in particular in manufacturing. We are in close contact with people from PSI and EPFL, and of course we have other contacts at various facilities in Europe and also worldwide. We offer different kinds of technologies, structures based on e-beam lithography with very high resolution, structures based on direct laser writing or with direct laser exposures with a little bit lower resolution, but extremely good properties for example, 2.5D structures with different heights. And we also we are able to use 2-photon polymerization, where we make very interesting structures for a lot of applications, and particularly in the X-ray optical regime. There are a lot of different structures we do with our e-beam machine, starting from Fresnel zone plates, which is basically our standard product, or one of our standard products. We do other structures such as beam shapers, which I will come to in a moment, gratings, test targets with various structure sizes, and also custom design gratings and custom design optical elements. With direct laser writing, we do also different sorts of gratings, micro lens arrays in 2D or 2.5D, Fresnel lens types, and various types of diffractive optical elements. With 2-photon polymerization, it is possible to make really all sorts of different 3D structures, which have been used in X-ray optical applications for various applications. One particular example is the 3D Siemens star, where we have 3D tomography reconstruction of this. This has been used and is in use for seeing and checking how well your system is set up if you have a tomography system, for example. Yeah, one of our standard products are Fresnel zone plates. We can make them out of various kinds of materials for various kinds of energies and with best resolutions or smallest structure sizes down to about 10 nanometers. This is also true for other types of gratings and structures as well. We also do full systems, optical systems, such as this one. This is a TXM setup, transmission X-ray microscopy setup, including full condenser, a test sample, objective lenses, and also phase rings for Wernicke phase contrast. One popular application or popular product is or are nanotest as well. As I said, we can go down to structure sizes to about 10 nanometers. And yeah, this might be interesting for some customers if you want to see if your system is set up properly. Of course, we also do other things and other microstructures such as gratings with from various materials such as silicon, gold, nickel, silicon dioxide, iridium, chromium, and diamond. And we also do etching into silicon, which might be interesting for some people. And also we do diamond optics or diamond structures, which may be useful for high power applications such as XFELs. One new application or one new product we have introduced quite recently. We now make our own silicon nitride membranes with various thicknesses between 50 and 250 nanometers. We can also accommodate your needs. We can make custom design membranes with off-the-center windows and also several windows if that is required. So if this is interesting for you, of course, you can yeah, come to me. I have a poster here at SXNS with some scientific applications of our technologies. This is poster number 88. So if you're interested in some scientific applications, please also stop by there. Two photon polymerization has been used for a couple of interesting applications. And this is a very interesting technology to really make real 3D structures, such as, I don't know, Eiffel Tower, for example. You could print out of this, so you're not limited to some 2.5D structures where you can only have spheres, but you can have real 3D structures. So you can think of this as a real 3D printer, or some sort of real 3D printer. It has a resolution down to about 100 nanometer. So this is the expected resolution of the structures you can get down to. And it can be variously quick, or you can write in various speeds. So also the precision can be changed depending on the properties you will choose for the beam. Now, I would like to show you some applications which this has been used for. So at the synchrotron, you often have compound refractive lenses, and due to manufacturing errors, you will not get an ideal and aberration-free beam or halo-free beam. And a colleague of ours, Frank Seiberot at DESI, has thought of a neat solution how to correct for these issues, and came up with the idea of making a faceplate. So you can think of this such as your glasses, if you're wearing any, to correct your eyesight. And these can be used for correcting the beam properties and focusing properties of existing optics, which you see here. So on the left side, you see a beam caustic without a faceplate, and on the right side, you see a beam caustic with a faceplate. And you see that this is much, much cleaner, and the focus does not have that many halo effects or side lobes as before using or as without the correction faceplates. This can also be used for different energies. So we have had examples for at about 8 kV, but also up to about 35 kV. These faceplates or these structures can be quite tall. This is an example of of a structure of about 800 micron in height, but the structures themselves, they can be even higher or taller. More advanced geometries are possible by using this 3D structuring. We can make kinoform lenses, we can make our own compound refractive lens arrays, and also not only stacked ones, but whole arrays, which can be used for multi-beam typography, which was done by a colleague of mine also at DESI, Mikhail Lubomirsky. And you can connect different technologies such as, or different structures such as these compound refractive lenses with additional faceplates you can print on top, which can be used to identify individual beams in this setup. As I've shown you, you can make and manufacture compound refractive lenses with this, focusing ones, but also on the other hand, defocusing ones. And quite tall structures, as I said. And you might be thinking, why would you need that? There was a paper about almost 20 years ago where Chris Jacobson et al. Thought about achromats and X-rays, and have been thinking that you could combine refractive lenses and diffractive lenses in order to get an achromat with X-rays. This would mean that you could focus over a wide range of X-ray energies, and this could be advantageous for many applications in X-rays. And we have demonstrated this using our technology by making Fresnel zone plates and combining them with refractive defocusing lenses. And we were successful in showing that we actually achieved achromatic focusing. So the focus doesn't change that much for quite a large range of X-ray energies, which has been done for the first time in the X-ray regime. Yeah, I hope you found something interesting. We as a company, of course, sell our products, but we also like to participate in developments and grant applications. If you have any ideas for collaborations, you can contact us and talk to me. And we're looking forward to have interesting discussions with you. Thank you very much, and I still wish you an interesting conference.